Algebra 2, Target 32, I can describe and compare sampling methods. Today the focus will be on understanding bias. What is bias? Well, a bias is when you have a population, you take a survey, and the way you survey it, you get a certain part of the population that gets more represented than another part of the population. The definition says a sample that overrepresents or underrepresents part of the population is biased. So your sampling techniques, you want to try and come up with ways to not overrepresent certain populations or certain subpopulations in your population. All right? Example. The manager of a concert hall wants to know how often people in the community attend concerts. The manager asks 50 people standing in line for a rock concert how many concerts per year they attend. Tell whether this is biased or unbiased. Explain your reasoning. Well, this is biased. If you're asking the general population a question about rock concerts or concerts in general, and you go and ask people at a rock concert, what you're doing is you're over-representing the people that actually go to the rock concerts. So this over-represents concert goers. So this is going to be biased towards a higher amount of concerts. How do you remedy that situation? It usually goes back to how you take your survey. The best survey, when possible, is to do random sampling. It is most likely to evenly represent the population. When possible. Not always possible or feasible to do random sampling, but it is preferred. Right? Another example. You are a member of the prom committee. You want to poll members of the senior class to find out where they want to hold the prom. There are 324 students in the senior class. Describe a method for selecting a random sample of 40 seniors to poll. All right. Lots of different methods. We want to kind of gear them towards random sampling. One thing you could do is you could walk to senior hall and talk to every 8 people. There's 40. You want to talk to 40. 40 out of 320 is 8. Right? That'd be one way you could do it. Another way you could do it, get a class list. And draw names. And then contact those people of the names you drew. These are just a few ideas of what you could do. All right? Read through this question if you can, pause it, and try and answer it. A computer science teacher wants to know if students would like the morning announcements posted on the school's website. He surveys students in one of his computer science classes. Identify the type of sample described and tell whether the sample is biased. Right? This is a convenient sample because he did it with students in his class. It was easiest for him to just ask them as they came in. And this is biased because it is biased towards you are over-representing computer users in your sample. When conducting a survey, you want to make your sample big enough so that you have a relatively small error. We calculate error so that we know how accurate. The margin error lets us know within a certain amount. So for example, we got 40% of people prefer a candidate with a margin of error of about plus or minus 4%. That would mean we can very likely say that 36 to 44% of the population prefer the candidate. All right. Now we calculate margin of error by looking at how many people we sampled. The margin of error goes plus or minus 1 over the square root of the number of people we sampled. The larger n, the less likely there is to be an error. And so the probability would actually range between your predicted probability minus margin of error and your predicted probability plus the margin of error. So let's look at an example. In a survey of 1,011 people, 52% said that the news is their main source of the television is their main source of news. What is the margin of error? Well, our margin of error is plus or minus 1 over the number, or the square root of the number of people sampled. So it's plus or minus 1 over the square root of 1,011. The margin of error here, 0.031, which is roughly 3%. So plus or minus 3%. So that means our actual interval would be between 52 minus 3% would be 49%. 253 plus 3% is 55%. So likely, not guaranteed, but likely, the number of people getting their news from television is 49 to 55%. Final question. In a survey of 1,202 people, 11% said they use the internet or email more than 10 hours per week. What is the margin of error for the survey, and how many people would you need to be surveyed to reduce the margin of error to plus or minus 2%? Well, first off, our margin of error is going to be 1 over the square root of the number of people surveyed, so plus or minus 1 over the square root of 1,202. That gives us a margin of error of about 2.8%, plus or minus 2.8%. And we want to increase our reliability to 2%. So that means we need to survey more people. Well, how many people do we need to survey to get 2%? Let's take our 2% written as a decimal and set it equal to 1 over the square root of n. And then we'll solve for n to see how many people we need to get. We'll multiply by the square root of n. We'll divide by 0.02. And then we'll square both sides. And that works out to be 2,500 people. We surveyed 2,500 people. Our probability of error reduces to about 2%. Right. So in summary, a bias is when you have a certain portion of the population over or underrepresented. And your error, you can calculate that by looking at the number of people you sampled and do plus or minus 1 over the square root of the number of people you sampled.